Welcome to the Explainer. You know, that device you're watching this on right now, it's an absolute marvel of engineering. But the technology that powers it, well, it's just about reaching its limit. Today, we're going to look at what's next. We're venturing into the future of computing, way beyond silicon. For like 50 years, Moore's Law has been the engine of the digital world, right? It promised us faster, smaller computers, year after year. But that whole era, it's coming to an end. The crazy demands of things like AI and just massive amounts of data are creating this huge need for processing power that our current silicon chips just can't keep up with. So at the very heart of this issue is a design flaw that's actually been with us since the very beginning of computing. It's called the von Neumann bottleneck. The best way to think about it is imagine a brilliant chef who can cook insanely fast, but they have to run to a pantry down the hall for every single ingredient. That's our modern CPU. It's constantly just sitting there, waiting for data from memory, and it creates this huge traffic jam for our hardware. And what that really means is, it doesn't matter how unbelievably powerful we make our processors, they will always be held back by this data transfer speed limit. It's this fundamental inefficiency that's really starting to stall progress in AI, in scientific research, and in solving all sorts of complex problems. Okay, so how do we break free from this thing? With traditional electronics kind of hitting a brick wall, two really revolutionary new approaches are popping up, and each one has the potential to totally redefine what's even possible in computing. So on one side, you've got the raw speed of light with photonic computing, and on the other, you have the truly mind-bending power of quantum computing, which it operates on the fundamental laws of physics itself. These are the two big contenders, and they're ready to take us into the next era. All right, first up, let's dive into the world of photonics. I mean, how exactly can you compute with light? Well, instead of pushing electrons through copper wires, which is kind of like trying to run through thick mud, photonic computing sends particles of light, photons, through optical fibers. And since photons travel at the speed of light, it's basically like going from a complete standstill traffic jam to a wide open highway. It allows for nearly instantaneous computation. And the advantages here are just, they're so clear. You get a huge boost in speed and bandwidth, and with way less heat, which is a massive problem for today's data centers. Plus, it's totally immune to electrical interference. It's just a much more elegant and efficient way to get things done. But of course, it's not all smooth sailing. This technology is still really in its early days, and there are some pretty big hurdles to get over. The manufacturing is expensive, getting it to work with our existing systems is a real challenge, and, controlling light is just a much more delicate and tricky process than controlling electricity. So, how does it actually work? Well, one of the key methods is called broadcast and wait, and it's perfect for the kind of math that powers modern AI. Think of it like this. Data gets encoded onto different colors of light. These colors then pass through these tiny little gates that adjust their brightness. And finally, a sensor just adds up all that light to get the final answer. It's a really simple, super elegant way to do some seriously complex calculations. And what is so revolutionary about this is that the computation happens while the data is moving. There's no more waiting around for information to get pulled from memory. This completely, totally eliminates that bottleneck we were talking about, the one that's been slowing down our current computers. It makes it absolutely ideal for the massive data sets that run our modern world. Now, let's switch gears and look at our other contender. This one takes us from the speed of light to the strange and mind-bending rules of the quantum realm. Okay, so your computer, my computer, they think in bits. It's either a 0 or a 1. Simple. A quantum computer, though, uses qubits. And thanks to this wild principle called superposition, a qubit can be both a 0 and a 1 at the exact same time. This lets a quantum computer explore millions of possibilities all at once, which gives it this unbelievable advantage for certain types of problems. But look, don't expect to be checking your email on a quantum computer anytime soon. These are highly specialized machines. They're designed for gigantic tasks, like simulating brand new molecules to discover life-saving drugs, or cracking the very encryption that protects our entire digital lives. These are problems that are just completely impossible for even the best of today's computers. But here's the catch. All that immense power is also incredibly fragile. Quantum computers have to be kept in ridiculously cold temperatures and shielded from the tiniest disturbances.
Seriously, even a stray vibration can cause a qubit to lose its special quantum state. That's a process called decoherence, and that introduces errors into the whole calculation. But even with those challenges, the field is moving forward, and fast. Google, for instance, is developing a new chip called Willow that's designed to tackle this exact problem of error correction. And as this quote really highlights, once we overcome this hurdle, it's going to be the key to unlocking massive breakthroughs in science, in medicine, and in finance.
So, the big question, is the future photonic or quantum? Well, the answer is it's both. Yeah, we're not heading for some big showdown here. We're heading for a collaboration. The future of computing is going to be a diverse ecosystem. Your laptop is not going anywhere, don't worry. Think of it like this. You wouldn't use a Formula One race car to go pick up groceries, right? In the future, we're going to have this whole garage full of specialized computers, and we'll just use the right tool for the right job, whether that tool is in our hands or somewhere up in the cloud. And this is pretty much what our future computing toolbox is going to look like. Good old silicon will still power our everyday devices. Photonics will be the workhorses, the engines of our data centers and AI. And quantum computers? They'll be the highly specialized instruments we use to solve the world's absolute biggest and most complex problems. And just to put that in perspective, photonics alone offers a 10 to 50 times improvement in bandwidth. For our data-hungry world, that is an absolute game changer. So what this all boils down to is a really fundamental shift in how we even think about computing. We're moving away from that one-size-fits-all approach and into a new era of specialized, purpose-built hardware. And it's that diversity that's going to fuel the next great wave of innovation. You know, this isn't just about making our computers faster. It's about building machines that can think in entirely new ways. And as this symphony of specialized hardware starts to come online, it's going to create possibilities that we can't even begin to imagine yet. The only real question left is, what new realities will we choose to create?